thank you so much for joining us, and thanks to our sponsors and of course our wonderful speakers. I want to begin by introducing our first speaker, who is Max Shine. He's an associate professor at the University of Sydney in the Brain and Mind Centre.
All right. Hi everyone, good afternoon. So thank you so much for the invite to be here. It's a real pleasure to be in such a gigantic room with lots of nice echo to talk to you guys today. I don't know why they put the Australian up first. They obviously want to set things off with a bit of a silly tone, so I'll do my best to break the ice a little bit and talk to you about my view of how we can do a better job of making the community, which is already admittedly a really nice, wholesome, engaging community for ECRs, make it even more engaging for people. So a little bit about myself first, just so you can get some context. So my group is really interested in just figuring out how to think about the brain in the right way. We're a little bit more theory-driven a lot of the time, but we use modeling and neuroimaging to try to understand the brain, really across scales as well. So we want to understand both how you could organize the brain at the neural level, different circuits of neurons connected together, but also how that might look if you scaled out to the level of whole brain imaging that we'd collect and often analyze at a conference like this. To do so, we use different kinds of techniques. So we spend a lot of time reading the cellular level literature in neurobiology. It's a real true love of mine to go and look into the literature and think about different types of cells in the cortex and the thalamus and the brainstem, try to figure out the rules of how they're connected, but also then coming out to the scale of neuroimaging, where we try to think about things like the bold signal, local field potentials, and measures that we can often get indirectly from humans doing tasks. Now, obviously, these scales look completely different from one another. If you've ever seen a spike train from neurons compared to a bold signal, they just look like they're completely different things. And that's for good reason. They're very different scales, spatially and temporally. But one of the things that we try to do to connect those scales together, rather than just talking about them, is to build models that are baked into the neuroanatomy that actually have constraints, but then see what those look like when we scale up to the higher level. But that's not what I'll talk to you about today. I'll talk to you what it's like being an academic in Australia and being part of a global community and doing my best to connect in with the community, but also trying to sort of think about some of the advantages and disadvantages of being on the other side of the world. All right, so this is the map of the world that they send out in schools in Australia. It looks a little different than the map you're used to, I guess. This is me in a plane when I was a student, a graduate student. I did my PhD at the University of Sydney after finishing med school. I worked on Parkinson's disease and trying to use neuroimaging to understand some of the weird non-motor symptoms that affect people with Parkinson's that aren't explained particularly well by normal models. After my PhD, I got a fellowship. I went overseas to work with Russ Poldrack at the University of Stanford. The first thing Russ said to me on my first day with him was that, you're not interested in working on Parkinson's, are you? And so I had to shift gears and think carefully about what I wanted to study. And what I really wanted to do was try to come up with better methods and techniques for actually taking the kind of neuroimaging data that we were collecting or that was in the community and actually try to bake in dynamics and neurobiological principles so we could actually understand some of the mechanisms a little better. After a really exciting couple of years, I flew back to Australia and have now started my own group, and I have lots of really lovely people that I work with, young scientists and collaborators that are established scientists, both in Sydney, but also in Newcastle and Melbourne and Brisbane. I also have some collaborators from South America. I had a grad student that's just graduated, Gabriel, and another postdoc, Vicente, who are both from Chile. I have lots of collaborators in the US and Canada that are really fun to work with from lots of different areas, and then groups in Europe as well. And the reason I put up this slide was to say that it's up to you to kind of create the connections that you want to create or that you'd like to create to help answer the questions you want. And I don't think that geographical boundaries should be boundaries for you. If there are people out there in the world that are an expert in an area or have techniques or data in a particular question that you would like to help answer, then I think people are really open to being connected with, and I'll try to demonstrate that to you today. But before we get to that rosy way of thinking about things, let's think about some of the challenges. So the timescales and time zones of working in Australia are just completely different to the way they are in the rest of the world. That makes that coffee is actually not really an ideal drink a lot of the time when you're in meetings, and oftentimes people use caffeine to spruik themselves up to be able to get the oomph for a talk. And we're often really far away from a lot of the really exciting and interesting stuff that's happening. So rather than thinking about these as challenges, I'm really inspired by this idea from an actor, Michael Caine, that he calls use the difficulty. So back when Michael Caine was starting out in acting, he was actually an actor on stages, on Broadway plays and things like that. And his character was standing in the wings one day, and he went to walk out onto the stage, and someone had left a chair right in the way as he was to walk out. And like many young actors do, I'm sure, he had a big tantrum and complained to his director, what's going on? Why is this chair in the way? Come on. And the director said, hey, calm down. Use the difficulty. If you're angry, smash the chair out of the way. If your character's sad, slump into the chair like you could never get out of it in a million years. And I really like this idea, right? There's always going to be roadblocks in the way. The question is, what can you do with that roadblock to make it work for you, for what you need in your particular circumstance? So let's think about some of the difficulties and how we can use them. So time zones differences are awful. I don't know how many times I've jumped onto a Zoom and I've gotten there an hour early or an hour later than my collaborator. It's just awful. Time and date is your best friend if you're trying to collaborate with someone in the Southern Hemisphere. I strongly recommend this. The seasons change with daylight savings. It can be really, really difficult to actually connect up. But there are some benefits too. So just recently I was writing a grant with a collaborator in Houston in the Baylor College of Medicine, and he had this really nice way of putting one of the benefits of us working together on a grant. So this is Jake Reaman now sitting on his chair. What Jake said was whenever he went to bed at night and he finished his edits, he'd wake up in the morning and all the edits that I'd done had actually come into his inbox. And so it felt like the duty cycle of the grant could speed up and we could actually get more done by working in serial rather than in parallel. So another way to say this is eat, sleep, write, repeat. But maybe a more fun way to think about it was that we're kind of on dueling pianos, except the pianos are MacBooks, and instead of beautiful music, it's us writing grants. All right. Another problem is that important meetings happen late at night when you're tired and you're trying to focus. This is really difficult. As I mentioned, evenings aren't always a good time for coffee. So my wife actually came up with an ingenious plan, which I'd like to share with you today. It's a do-it-yourself little list. So what you do is you take a teacup, right? And you get a tea bag, but then you get out your scissors and you cut off the tea bag. And then what that leaves you with is this little bit of string, right? And then what you do is you get the tape and you put the tape on the inside of the cup, and then you pour in whatever you like. It doesn't have to be alcohol if you don't like to drink alcohol, but for me, I do. And so you put a little bit of alcohol in, and then when you're on Zoom, hey, you're drinking a cup of tea at night. This is just to say that you don't have to let these things get you down. Sometimes you need to look for problems, ways around solutions. All right. Another problem is that people don't often work on Sundays. So in the Northern Hemisphere, the Sunday for them is your Monday. So you get to work on a Monday, you're raring to go, you want to get some work done. People don't usually work. So one of the things that we do in my lab is we often use Mondays as a personal day. An example of this is one of my postdocs, Eli Muller, who's just been spending the last 2 weeks in Indonesia surfing. That's him there on a Monday surfing. And so I think one of the things that's really important to embrace is that if people aren't working on the day that you would normally work, maybe you can shift your week around and make it work for you. Another problem is that we're almost always jet lagged at conferences. I think a lot of you will now know what I'm talking about. Pretty much every other HBM I've been to, I've been pretty jet lagged. But that can be useful, but it's also probably worth admitting to yourself that a conference isn't going to be the best place for you to go and be looking at equations and trying to figure out the precise details of a problem. What I say to my students, and I try to remind myself, is that it's good to focus on trying to understand something when you're at a conference. Don't worry so much about the real details, but just try and grok the concept. And if you do that, you might look a little silly sometimes if you're jet lagged, but you'll actually find that you can actually get to the bottom of problems and then set up connections for later. All right, this is an actual photo from HBM Glasgow, the first time people did in-person meetings. And then this is the photo of Australians. We couldn't afford flights because everyone was trying to go home to see their family, which admittedly should take priority over science, I think, but it was very hard for us to watch all these things from far away. But rather than just feeling sort of socially isolated, I think the real problem is that we aren't around for these really important kind of water cooler conversations, right? Not just seeing the great paper that comes out or the really, really cool keynote that you saw recorded on YouTube, but rather hearing people have chats about, oh, did you see that paper? I wasn't so sure about that. And you miss a lot of that. So one of the things we tried to do to use that difficulty is we started focusing our Zooms when we were doing Zoom meetings on what we call Zoom journal clubs. So what we do here is we find people that have put out a really cool preprint. We try to focus on the ECR, and what we do is we invite them to come present to our group, but really just present the figures of the paper. We don't want to see a big glossy talk. We want to see the nitty-gritty. How, what were you thinking? What were the things that didn't work? How did you get to the bottom of it? And the important part is that for my students, I really wanted them to see what it's like to actually do the science. I don't want to see the outcome, I want to see the process. So in other words, I want to see how the cake is made. And I think this is a really, really important thing that as ECRs, you can really sort of step up and take these opportunities and really reach out to PIs and say, look, I admire your work, I did some work that's relevant, would you be willing to hear me present some of my work to your group? And I think most people in the community are really open to these kinds of opportunities. If you are interested, we run a small little group called Systems, Neuroscience and Complexity. It skews a little mathsy and dynamical systemsy, but if you're interested and you think you're doing work that we would like, please reach out. We're really happy to have people come along and present. Just to show you that reaching out to people who you admire is not just lip service, I'll just give you a couple little vignettes. So back when I was working in my postdoc, we had a paper that we published. It was on thinking about how network dynamics could relate to cognitive function. But I'd worked on this paper for a while, and then I one day was absentmindedly checking my junk email, and I realized that I'd been invited to review a paper by Olaf Sporns, who was one of my personal heroes in network neuroscience. And I was like, oh, what have I done? I've just let this opportunity go to waste, and I look like a flake. I haven't done the work. So I reached out to him and asked if we could have a meeting. We ended up having a Zoom, and fast forward a couple of years, and we actually got to work on a paper together that ended up in Nature Neuroscience. It was a really, really fun paper to work on as a kind of integrative collaborator. So, you can essentially, by taking those opportunities, you can actually find connections with people that you really admire in the field. Just to make you think this isn't just like an ECR thing, I still do this as a PI. So this is a theoretical paper that I worked on a couple of years ago during the pandemic when I was geeking out on thalamic neuroanatomy. There's some implications for that work for a very particular type of cell in the cerebral cortex called a layer 5B pyramidal neuron. And there's a world expert that works on this in Berlin, Matthew Larkham. Out of the blue, I sent him an email, love your work, would love to chat with you sometime. And we now collaborate together, and we've done some computational modeling work that tries to connect his kinds of insights from the cellular level to the kinds of measures that we think are really important. And so this is a picture of my two postdocs, Brandon and Eli, and Matthew's gigantic beer in Berlin, where we went to a beer hall, and we actually got to watch Matthew play violin in a philharmonic in Berlin, which was really a great experience. And there's even more examples. So I did some theoretical work thinking about different arms of the arousal system and how they might impact whole brain dynamics. And the real godfather of this field, Laszlo Zaborski, really lovely individual. We interacted a few times over email. And then we've now just been able to do some work together. And so this is me when I got to meet Laszlo by accident at SFN a couple of years ago. So these end up being some of the most enriching experiences for me as a young scientist, where I can take an idea, find someone whose work I admire, reach out to them. It's really scary to do it, but when you do it, you get these huge rewards of actually doing work that you really, really believe in. And I couldn't encourage you to do that anymore. Despite all of this, we live a really long way away, and so oftentimes our shouting goes off into the void. But I think that really helps to motivate us to figure out how to connect together. Because we're so far away, there's a real incentive for us to figure this out. And also to really put the work into building a great local community. So Australia's got a really, really great community distributed across the eastern seaboard mainly, but we have a really vibrant OHBM Australia chapter. Hopefully we'll be able to show you a little bit of that next year for all of you that come to Brisbane. And so with that, I'll say thank you very much for listening, and I'm more than happy to answer questions a bit later. Thank you.